Hey, it's similar polygon time, and we're going to be looking at, oh my goodness, the perimeter and area of similar polygons. That sounds pretty fascinating. So let's take a look at the perimeter. So we've got a couple of really nice triangles here in their native habitat. The claim is that they are similar. Well, let's make sure they really are. Okay, let's make sure. Let's see, 3 compares to 6 is 1/2. 4 compares to 8 is 1/2. 5 compares to 10 is 1/2. Okay, they really are similar, and the scale factor k is 1/2. Okay, let's take a look at the perimeter. Of course, perimeter is always easy because for any polygon, you just add up the sides. 3 plus 4 plus 5 goes 12. Now, if they were labeled as feet, I would have said 12 feet. If they're labeled as miles, I would have said 12 miles. If they're labeled as meters, I would have said 12 meters. If I don't see a label, sometimes I get lazy and just put 12, but if I was a good mathematician, I would say 12 units. Of course, for the larger triangle, looks like it's 24 units. And then, surprise, 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 the ratio of the triangles is 1/2, which is the same as the scale factor k. Well, that's easy. Perimeter has the same scale factor as the sides. So there's your official definition, stolen from the textbook if you want to take a look at an official definition. Sure enough, if the polygons are similar, the ratio of their perimeters is equal to the ratios of their corresponding side lengths, right? They're the same factor. That was super easy. Let's look at the area. Same 2 triangles, so we already know that the scale factor k is 1/2. Of course, area of a triangle, 1/2 times the base times the height. So in a triangle ABC, looks like the base is 4. It looks like the height is 3. And we end up with an answer of 6. Of course, instead of 6 units, it's 6 square units. And for the larger triangle, DEF, again, 1/2 times the base times the height. Base is 8, height is 6. And we come up with 24. 6 compares to 24? That's 1/4. 1/4 and 1/2 are not the same thing. We better investigate a little bit more. This time, hey, let's look at rectangles, change of pace. Again, the claim is that they are similar and that they are rectangles. Let's make sure we can figure out the scale factor. Looks like the scale factor is 1/3. Okay, area. Rectangle, a lot easier, length times width. So smaller rectangle looks like 2 times 5, which is 10 square units. Larger rectangle looks like 6 times 15, which is 90 square units. And so the ratio is 10 over 90, which is 1/9. Whoa, what's going on here? When k was 1/2, the ratio of the areas was 1/4. When k was 1/3, the ratio of the areas was 1/9. What's happening? Hey, 1/2 times 1/2 is 1/4. 1/3 times 1/3 is 1/9. The ratio of the areas, it's not k, it's k squared. Ooh, because area is square units. Oh, this is so exciting. Again, stolen from a textbook, Big Ideas curriculum, closely aligned with our state core curriculum. Sure enough, if the polygons are similar, then the ratio of their areas is equal to the squares of the ratios of their corresponding sides. So it's a square of the ratio factor. Okay, let's get down, exciting. Do an example because I know you want to put pencil to paper here in just a moment. So find the perimeter of the area of the trapezoid. All right, so we got to find the perimeter, got to find the area. Again, perimeter is a piece of cake. Add up each side. Looks like the perimeter is 42. 42 feet to be more precise. Area. Of course, with a trapezoid, we're talking about, yes, thank you, Tinkerbell and Hannah. We're talking about a trapezoid. We got to average the bases and multiply by the height. So I've got base number 1 plus base number 2 divided by 2 times the height. 8 plus 12 over 2 times 9. So it looks like we come up with 90. All right, so for the original trapezoid, we've got a perimeter, we've got an area. We know the scale factor is 2/3. So the rest of the directions are like, hey, if the second trapezoid were created with that scale factor of 2/3, what would be the perimeter and area of the new trapezoid? Well, for perimeter, we take the previous answer of 42. We multiply it by the scale factor of 2/3. And we come up with 28 feet. For the area of the new trapezoid, we have to take the previous area of 90, but multiply it by 2/3 quantity squared. So it's 90 times 2/3 times 2/3. And we come up with 40 square feet. Okay, I'm sure that you're dying to get pencil put to paper. So if these could hold still for just a moment, we would see exactly what is happening. Oh, right now the background's too dark. Can anything go right today? Oh, look at that. That's better. So we've got a worksheet for Unit 8, Lesson 2. And then on the IXL, it's P2, similarity statements.